module, next chapter, first module we are going to discuss. So in this chapter, we are going to discuss the various shift keying techniques, namely amplitude shift keying, frequency shift keying, and phase shift keying, and the upgraded versions of PSK. And let us go through the basic introduction session regarding the various line encoding formats as well as the different digital techniques, digital communication techniques. Now, so coming to the various line encoding formats, here you can see this is NRZ line, so non-return to zero. So here if you see this is a binary string, 1010 110010. This is one binary string. In that binary string, if you want to represent using non-return to zero line space, here here one forces a high level and zero forces low level. So here you see that this is a non-return to zero level. This is a standard positive logic used in various distance circuits. Here one just a force to high level and zero force to a low level. Similarly, second type of representation is non-return to zero mark. Here one forces a transition. Wherever you have one, there will be a transition, and for zero, there is no transition. So same data will be continued. Again, at one, you will have a transition. For zero, you have no transition. So wherever you have one, there will be transition from high to low or low to one. Similarly, third one is non-return to zero mark. So third one is non-return to zero space. In this one does nothing. So here one as usual zero will be there, and wherever you have zero there will be a transition. So again one there is no transition. So same data will continue. So these are the three types of non-return to zero types of line encoding formats. And coming to these formats here, you can observe non-return to zero. So in the middle, it doesn't return to zero. That is called as non-return to zero type of representation. And next type of representations you can see is return to zero, RZ. So here in the return to zero, one goes high for half the bit period. Here one goes high for half the bit period, and after completion of half duration, it will go to low. So in the middle of the bit, so you will have a return to zero or return to zero transition. And for zero, there is no change. So this is about the return to zero type of encoding. And the next one is biphase line. In the biphase line, this is also called as Manchester coding. So here two consecutive bits of same type force a transition at the beginning of the bit period. So two consecutive bits. For example, if you have 1 here, so two consecutive bits have a transition, have like a transition here at the beginning. So again, at 1 you will have a transition at the beginning, and for 1 you will have a negative transition in the middle, and for 0 you will have a positive transition. But whenever you have two consecutive bits, there will be a transition at the beginning of the bit period. Otherwise, there is no transition at the beginning of the bit period. And second one, next one is biphase type mark. In this, there is always a transition at the beginning of the bit period. So, irrespective of the consecutive bits or whatever it may be, at each and every bit starting of the bit, there will be a transition. For example, if it is 1, there is a transition. 1 forces a transition in the middle. For 0, there is no transition. There will be transition only at the beginning of each and every bit. And the next is a biphase space. So in this biphase space, there is always a transition at the beginning of bit period, similar to biphase mark. And here for 1, you can see that there is nothing, no change in the middle. For 0, you will have a transition that may be low to high or high to low, but there is a transition in the middle for 0. And always transition at the beginning of any bit period. But for 1, there is no transition in the middle of the bit. And next one is differential Manchester. There is always a transition in the middle of the bit period. In the middle, if you see, there is always a transition. For one, it doesn't nothing. It doesn't have a transition at the beginning, and for 0, there is a transition at the beginning. Here it is a 0, so there is a transition at the beginning. Again here 0, so low to high transition is there at the beginning of the bit period. But for 1, there is no transition in the beginning. Only transition is in the middle of the bit period for both the bits. Next one is bipolar. So in the bipolar, the positive and negative pulses will alternate. Here you can see one forces a positive or negative pulse for half of the bit period. For 0, there is no transition. And the positive pulses and negative pulses will alternate. But for 1, there is a positive or negative pulse for half of the bit period. For half of the bit period, you will have a pulse for 1. And for 0, there is nothing. And these positive and negative pulses will alternate throughout the system. And coming to the different types of digital modulation techniques, in the digital modulation, we will take the input message signal as digital, and the carrier signal, we are taking it as a continuous. Because carrier is continuous in nature, we can vary either the amplitude or the frequency or the phase of the carrier with respect to the amplitude levels of m of t. That may be either 1 or 0. So in amplitude shift keying, the amplitude parameter of carrier signal will be varied in accordance with the input binary signal. In this ASK, the frequency and phase of the carrier remains constant. And in FSK, the frequency of carrier signal is varied with respect to the input message signal by keeping the amplitude and phase of carrier as constant. In PSK, only the phase of the carrier signal will be varied with respect to the input signal, that may be either 1 or 0, 2 levels, by keeping the amplitude and frequency of PSK as constant. So here you can observe the waveforms of amplitude shift keying, frequency shift keying, and phase shift keying. In amplitude shift keying, you can observe that there is amplitude variation. For data bit 1, you will have same amplitude at carrier, and for data bit 0, you will have no amplitude, that is 0 amplitude. So here, because it is a 0 amplitude, there is during the transmission of 0 bit, the power required is, no power is required for transmission of data bit 0. And here you will have only amplitude variations, so it is highly susceptible to noise. And second type is frequency variation. If you have the message data bit is 1, then you will have a higher frequency. For the data bit 0, you will have a low frequency. Here, high frequency can be observed by compression over time. And similarly, low frequency can be observed by expansion over time. And because there are no amplitude variations in FSK and PSK, this is somewhat, these two are noise immune, the FSK and PSK. And similarly for FSK, it needs a larger bandwidth because a high frequency, 2 different types of frequencies we have to produce for a binary shift keying technique. Similarly, in the phase shift keying, here you can observe a phase change from a 1 to 0 bit transition or 0 to 1 transition. You can observe a phase change of 90 degrees for binary phase shift keying. And out of the 3, PSK is highly robust towards interference. And coming to the different types of detections, we can discuss, there are 2 different types of detection. One is coherent and another is non-coherent. In the coherent, a synchronous carrier is used. That is synchronous in terms of both frequency as well as phase and as well as timing synchronization. It should be synchronous in terms of frequency or phase and timing synchronized. It is the carrier must be frequency or phase locked to the carrier used at the transmitter section. So it is somewhat a complex technique, but it gives the accurate result. In the non-coherent detection, we doesn't use any kind of carrier, synchronous carrier. That is the frequency and phase of receiver carrier must match with the frequency and phase of transmitter carrier, as well as it should be like provide timing synchronization. So here, no use of synchronous carrier in non-coherent detection. Here the implementation is easy, but doesn't produce an accurate result. If you see the differential phase shift keying, it is one of the non-coherent version of binary PSK. In this, you can see different types of applications of shift keying techniques. If you see frequency shift keying technique, it's earlier it's used in cordless telephony or paging services. Phase shift keying, initially they used for telemetry, and nowadays for cellular telephony, we are using QPSK, and for satellite communications, we can use 8-array PSK, and for broadcasting purposes, QM. Similarly, different types of queuing, this 16 array or 32 level or 64 level. So all of these are preferred for broadcasting purposes, and a minimum shift keying technique is also used for cellular telephony. In this module, we have discussed the introduction to various line encoding techniques, and then the next module we can discuss the amplitude shift keying. Thank you for listening.